This is Trigonometry, Chapter 7, Section 1, Oblique Triangles and the Law of Sines. What the heck is an oblique triangle anyway? Well, we've gotten special understanding over right triangles. This uses the trig definitions, opposite, adjacent, hypotenuse. But suppose you have a triangle that is not a right triangle and all the sides are different. We've even had equilateral triangles that we can figure out because we can make that into two right triangles. Well, an oblique triangle is something that's not as nice as all this stuff. So what we'd like to do is figure out some of the ways of solving these right triangles, the 6 parts, the 3 angles, and the 3 sides. In order to do that, let's first of all think about, from geometry, those possible situations where we had congruent triangles. Angle, side, 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 angle, side, and angle, angle, side. Now there are 2 others, angle, 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 and angle, side, side. A lot of books would call it side, side, angle because they didn't want to have that bad word in there. But the angle, angle, angle situation was just similar triangles. And the angle, side, side was a special situation that you may or may not find 1, maybe 2 triangles, maybe none at all. But these 4 proved that you had congruent triangles when you did the angle, side, angle, and such. So those are the ones we're going to use to figure out there's a law of sines, there's a law of cosines. How do you figure out the law of sines? Well, there's 2 cases. If we take a look at a triangle and we cut that into 2 right triangles because we make a perpendicular from one of the angles to the opposite side. And let's assume that it's sort of nice. It's not where this altitude is outside the triangle, but inside. Let's call this angle A, this angle B, this angle C. Remember, this is not a right triangle. Only these that we created are right triangles. We'll call this point D. This is H, the height. The side opposite C is little c, the side opposite A is little a, and this entire side is little b. Now, if we'd use some of these smaller triangles, what is the sine of angle A? Using this little triangle, it is H over C, opposite over hypotenuse. What is the sine of angle C? Using this smaller right triangle, angle C is the opposite H over A, the hypotenuse. Well, both of these equations have in common that H. So if we solve for H, here we get C times sine A, here we get A times sine C. So C times the sine of A is equal to H, which for this other one is equal to A times the sine of C. We're just solving for H here and then setting them equal. So don't worry about that H. Get the H out of there. So now we have C sine A is equal to A sine C. If we divide both sides by the sine of A times the sine of C, sine of A, sine of C. Now the only time we'd have to worry about that is if one of these angles would cause this to be division by 0. But since this is not any right triangle, we don't have to worry about that. So these sine A's cancel, and the sine C's cancel. And we get C over the sine of C is equal to little a over the sine of capital A, or angle A. And so this is one form. Now, your book might flip these over and say sine C over little c is sine A over little a. That's the same thing. You just have to flip both of them over, and that would be true also. You can do the same thing with this angle B, and you'll get little b over sine of angle big B. And once again, you could flip all three of those, but that is the law of sines. Now you might say to yourself, well, hold on. Just suppose that that height is outside. In other words, let's suppose that our triangle is like this. And now for this extended side, and this height perpendicular is h. Well, let's see. We'll call this B, this A, and this C. Doesn't really matter. The side opposite A is little a, the side opposite B is little b, the side opposite C is little c, and then of course that's h. Now, the angle, this is angle A right here. What is this angle right there? Well, it's 180 degrees minus angle A, right? We have to keep that in mind. So first of all, the sine of angle C is the opposite. Remember, we need to write triangles here, which is h, over the hypotenuse, which is A. So once again, A sine angle C is equal to h. Okay, we've got that. We can also see, hopefully you can see, that if you use this little angle, 180 minus A, what is the sine of 180 degrees minus A? Well, that's using this little bitty triangle here. It's the opposite, h, over the hypotenuse, C. So C, sine of 180 degrees minus A is h. Well, let's work on this for just a second, because the sine of 180 degrees minus A is not very helpful for having a law of sines. But we can take this C times the sine of the first, sine of 180 degrees, the cosine of the second, A, and for the sine of this difference, it's subtraction, the same, the cosine of the first, 180 degrees, and the sine of A, that equals h. So C times, what is the sine of 180 degrees? Well, if you looked at that, let's see if I've got this here. Yes, I do. Okay. The sine of 180 degrees, remember this is the point 10, this is the point 0, 1, this is the point -1, 0, this is the point 0, -1. 180 degrees is here. The sine is the y coordinate, which is 0. So sine of 180 is 0 times the cosine of A, minus, what is the cosine of 180 degrees? Well, it's that same spot. For 180 degrees, it's a -1. So -1 times the sine of A, that's what equals h. So this is really C, negative, that makes it a positive. This is out of here. Sine A equals h. So we have, as before, h is equal to A sine C, h is equal to C sine A. So C sine A equals A sine C. Divide both sides by the sine of A, sine of C, both being non-zero. The C sine C's cancel, the sine A's cancel. C over sine of angle C is equal to little a over sine of angle big A. Do the same thing for the b and the sine of big B. The law of sines. That's what 7.1 is all about. So let's go through an example for section 7.1. If we're given an angle B is 38 degrees 40 minutes, angle C is 91 degrees 40 minutes, and side A is 19.7, the first thing you should do is draw a picture. Doesn't matter exactly. A, B, C. Little a is across from big A, little b across from big B, and little c across from little c. We have angle B, we have angle C. To find angle A, we just have to subtract those from 180 degrees, right? Minus the 38, 40, and minus the 91, 40. Let's see what we get from that. (180 minus the 38 degrees, 40 minutes, minus the 91 degrees, 40 minutes, gives us 49 2/3. Well, 2/3 would be 40 minutes. If you didn't realize that, you could then change this in that second apps where you get the degrees and the minutes. Number 4 is called DMS, degrees, minutes, seconds. And you can put a 4, it'll take that answer, change it to degrees, minutes, seconds, which is the 4940. Okay, so if we know then all of those, let's make a list of all of those sides. Here's angle A, angle B, angle C. We know angle A is now 49 degrees and 40 minutes. Angle B is 38 degrees, 40 minutes. And angle C is 91 degrees, 40 minutes. Awful close to a right triangle. But now side A, side B, and side C. Side A is 19.7 centimeters. We got to find the other two. Let's see here. If we know that the 19.7 over the sine of 49 degrees 40 minutes is the same as B, which we don't know, over the sine of 38 degrees 40 minutes, which is the same as C, which we don't know, over the sine of 91 degrees 40 minutes. We can take two of these at a time. B is equal to cross multiply 19.7 times the sine of 38 degrees 40 minutes divided by the third, the sine of 49 degrees 40 minutes. So B, if we take our calculator, (19.7) times the sine, 38 degrees, 40 minutes, divided by the sine of 49 degrees and 40 minutes gives us 16 point, let's see, we're in one decimal place with this. We'll do the same thing, 16.1. I got 146, but unless you get greater than. Also C, if we use this first one and the last one, C is equal to that 19.7, the sine of 91 degrees 40 minutes over the sine of 49 degrees 40 minutes. Boy, that's getting harder and harder to read. So use the same idea. Clear this out. 19.7 times the sine of 91 degrees sine. Yep. 91 degrees, 40 minutes, divided by the sine of 49 degrees, 40 minutes. And it gives us 25.83. So 25.8 centimeters. Now you always have to make sure you're in the correct mode. I was in degree mode all the time. And these will be then your answers. The last thing in the 7.1 talks about the area of a triangle. If you wanted to find the area of a triangle, the area is equal to the base times the height. You take half of that, all right? Half the base times the height. Well, if you don't have all that stuff, you can use some of your information about the law of sines. The base so let's add some things here. Because we call that B, let's call this angle B. Let's call this A, so that's little a, so this will be C and little c. So we also know that the sine of A in this right triangle is h over c, which means that h is equal to c sine A, just like we did before. And so we can plug that in for the h. So instead of 1/2 the base times the height, it's 1/2 the base B times C sine A. Well, notice what that gives us. The B and the C and the A are part of a side angle side situation. This works for any angle and its adjacent sides. So you could also have 1/2 AB sine C. Here's the A, here's the B, and the sine C. Or it could be 1/2, and I guess the angle is what you can use to sort of guide you. If the angle is B, then you have to use A and C. So in a sense, you have all three letters, ABC, ABC, ABC. And you can use that to find the area of any triangle.